Today we are going to be demonstrating the effects of buoyancy in a fluid. Buoyancy is a force related to the relative density of objects or fluid parcels within a fluid. The force of buoyancy is defined by the gravitational force of the volume of fluid that is displaced. In the case of this demonstration, the force of buoyancy upward for the fluid will be greater than the force of gravity, so it will begin to rise. This buoyant force can have some interesting effects. This includes the generation of both mean and turbulent kinetic energy. The equations given on screen show this effect in a production term. This kinetic energy will be shown later. Additionally, in the equations is a term for viscous dissipation, which will be responsible for the loss of this energy over time. On to the demonstration. First, we are going to need some supplies. We have distilled water, some clear glasses, assorted colors of food coloring. We're going to be using 3 different types of alcohol, including 40% ethanol, 75.5% ethanol, and 91% isopropyl alcohol. In addition, we are going to need a few pipettes, some white paper, a ruler to measure the height of the water, and some tape. To get started, fill a tall glass with the distilled water. Then, pour out a bit of the first type of alcohol into another glass, add food coloring, and mix well. From here, set up the demonstration area using the white paper as a background. Measure the height of the water to get a sense of how far the buoyant fluid is traveling. Now we can begin the demonstration. Use the pipette to collect the alcohol and food coloring mixture. Release the alcohol mixture into the bottom of the glass and allow buoyancy to take effect. We can see that the alcohol, which is a lower density than water, rises to the top of the container. As the alcohol begins to rise, it begins to diffuse into the fluid, but it still rises upward. The isopropyl alcohol has the lowest density, so it therefore rises the fastest. Notice as the isopropyl alcohol and 75.5% ethanol hit the surface of the water, a shock wave is sent out as the kinetic energy of the upward moving alcohol is dissipated into the surface of the water. This is the mean kinetic energy that was generated by buoyant effects taking action. Over time, the fluid begins to stratify as the kinetic energy is dissipated by viscous dissipation. Also, there is some alcohol that is moving slower or downward despite the overall buoyant force being upward. This is the turbulent kinetic energy in action. The turbulent kinetic energy can be seen in the isopropyl alcohol demonstration. Looking at the top of the water when the alcohol reaches that height, coagulated food coloring is launched upward by the kinetic energy that is generated by buoyant production. The viscous dissipation is seen in the ethanol experiment when the alcohol reaches the top of the container. The alcohol begins to mix as the motion begins to slow down.